Okay, so now this system is called the general solution of this equation. Just like we have done in the differential equations, there was some general solution, and then there was some solution for the homogeneous part. So in this case, if the equations are homogeneous, so for example, instead of these values 5, -7, and 6, the values are 0, 0, 0. So then what will be the solution? Whether that solution can be written out of this general solution or not. So the answer is yes. So in this case, if these coefficients are, say, if we change these coefficients to, say, 0, 0, and 0, so the solution of this system, instead of this system, that will be the homogeneous system. Okay, that will be called as the homogeneous system. So the solution will be contained in this general solution. So in this case, the solution will be the part where you will have these S1 and S2 values. So if we call this as a general solution, so the homogeneous solution will be a part of the general solution, and then that will be S1 times -3, 1, 0, 0, 0, and then S2 times 1, 0, 2, 4 by 3, and 1. Okay, in other words, it will be minus 3s1 and minus 3s1 plus s2, and then it will be s1, and then it will be 2 s2, and then it will be 4 by 3 s2, and then it will be s2. So this will be the solution of the homogeneous part. So this solution can be extracted from the general solution. Okay, so this here I am just telling you about that, but I need to also show it whether it is really that part. So for this I can write this system into the augmented matrix. Okay, and then we can prove it. So the augmented matrix will be in this case it will be easier if I, instead of augmented matrix, because that will be 5 by 3 matrix. Oh, okay, maybe I can write it in the augmented matrix form, or I can just directly solve it. Maybe I think in this case I would directly solve it. Okay, so let me take the last equation. So the last equation is this one: 3x4 minus 4 x5 is equal to 6. So 3x4 minus 4x5 is equal to 6, but for the homogeneous it will be 0. So now x2, x5 we have taken as s2 as the free parameter. So in this case x4 will be then so x5 is we have taken as s2, so it is the same. So x4 will be now 4s2, 4s2, and then divided by 3, so 4 by 3 s2. So it is same as this. Okay, so from the previous equation we can take x3 minus 6x4 plus 10x5. So x3 minus 6 x4 is now 4 by 3 s2, 4 by 3 s2, and it was plus 10x5. 10x5 was also s2. is equal to 0. Okay, because homogeneous, we are considering the homogeneous part. So in this case now what it will be, so it will be minus 8s2 plus 10s2, it will be plus 2s2 and plus 2s2, sorry, it will be plus 2s2, right? So it will be minus plus 10 and minus 6, it will be plus, so x3 will be minus 2 s2, but whereas we have the answer as plus 2 s2. Did I make any mistake? Yeah, yes, in fact it was minus 2 s2 in the general solution. The answer was here, so it is minus 2, and it should be minus 2 here and minus 2 here. And similarly from here we can get x3 is equal to minus 8 s2 plus 10 s2 is plus 2 s2, and then x3 will be minus 2 s2. And from the first equation, x1 plus x2 plus 3x4 minus 5x5 is equal to 0. So x1 plus x2, but now we will take x2 is equal to the first free parameter, that is s1, and then plus 3x4 plus 3x4, x4 was 4 by 3 s2, and minus 5x5, 5x5 was s2, and that is equal to 0. So this is the first equation. So it will be x1 will be now minus s1, okay, and then this is plus s2, minus s1 plus because it will be minus 5s2 plus 4, it will be minus s2, and then when it goes to the other side, then it will be plus s2. So what solution which we get now over from here, x1 was minus s1 plus s2, so it will be s1, okay, and s1, sorry, it will be minus s1 plus s2, and then x2 will be of course s1, and x3 is minus 2 s2, and x4 was 4 by 3 s2, 4 by 3 s2, and then it is s2. So we can write it like this, s1 times minus 1 1, and then 0 0 0, because there is no s1 term over here, and then we can write like this, s2 will be 1 0 minus 2, 4 by 3, and then 1, so which is the same as before. Okay, yeah, the only difference was that earlier we made some mistake in putting minus 2 over here. Okay, so it means that what I wanted to convey was that the homogeneous solution can be obtained from the general solution. Okay, and that will be in terms of the free parameters. So the term without the free parameters will not be in the homogeneous solution. On the other hand, if for example we will have 5 equations over here, and then all equations are homogeneous, so then there will be no non-trivial solutions. All the trivial solutions will be x1, x2, x3, x4, x5 will be zeros. Okay, so next let's do one more. That may be the last example here. So again, if for example I take it as like example 4. We have this matrix 1 2 2 0 1 1 and minus 2 2 3. So whether the columns of these matrix are linearly independent or not. So we have done it many times before. Apply the row operation. So what row operation we will take? So minus 2 r1 plus r2, that is r2, and minus 2 r1 plus r3, that is r3. So it will be 1 0 minus 2 0 1 and 4 plus 2 is 6, right? It is minus 2, so it will be plus 4 plus 2 is 6, and next it will be 0 1 and then 4 plus 3 7. Okay, now what row operation I will apply to make it into the echelon form. So minus r2 plus r3, that will be r3. So what I will get is 1 0 minus 2 and 0 1 6 and then 0 0 and then 1. So what I have got is an echelon form. Okay, so this echelon form will provide a unique solution if there are some non-homogeneous terms in ax is equal to b. Okay, so which means that these three columns are linearly independent. Or if b is a null matrix, that is 0 0 0, so all the values for a x1 x2 x3 will be 0, so which is also the condition for the linear independence of the three columns. These represented by of the three vectors represented by these three columns.